A gear ratio lower than 1 is called an overdrive, and this type of gearing results in a higher speed at the output compared to the input, but less torque. For example, an overdrive ratio of 0.5 results in the output speed being double that of the input, with the output torque being half that of the input. Don't worry if you don't totally understand this, because gear ratios are still confusing to even me, but just some general info about these gears. Next, we have bevel gears and a worm drive. So these look pretty familiar. They look like the shape of a gear, but not exactly what you might think. So bevel gears work on the same principle as regular gears that we typically see, but as you can see in this image below, the input and output shafts are perpendicular to each other. So this gives you a unique range of motion and can be useful in a handful amount of specific circumstances and situations. A worm drive uses a screw and a regular gear to transfer motion by 90 degrees. One rotation of the input screw advances the output gear by 1 tooth. Worm drives can net insanely high reductions relative to their size. So that image below is an example of a worm drive. You see just a regular gear and then a screw on top. Next, this is our robot from the 2020 to 2021 season for FTC Robotics. And as you guys know, we are the Ravenets robotics team. So in this robot for the competition season, you can see that we use some bevel gears. You can see the perpendicular orientation of those gears there. And we have quite a few other features on this robot that are very neat as well. And yeah, pretty cool. Some more info about intakes and manipulators, which are some new topics. And this is specific to FIRST Robotics. So in FIRST Robotics, each year there's at least one manipulatable game element. And it's necessary to have a mechanism to intake and deposit these game elements. And we see the game elements, some examples down here. One year it was like the rings, one year it looked like these Lego sort of bricks. One year was these balls. Pretty neat. So we have passive intakes, which include claws and grippers that can pick up individual objects. And essentially passive intakes are mechanisms where the driver must pick up individual items, which can just hold that game element, but it requires good coordination on part of the driver. A claw is an example of a passive intake because it can just only pick up one item. So they're really useful for picking up large elements that cannot be controlled by active intakes, and we'll get into active intakes later. Claws are very common for passive intakes, and they can only be made with servos, meaning only like a specific amount of degrees for their range of motion. And listed here, some more advantages and disadvantages. They are very reliable because they take a lot less time to build and there's less moving parts. Disadvantages include their speed. They're very slow and require a very skilled driver, and they can be quite fragile at times. Next, active intakes. These are mechanisms that will continually intake game elements as long as the driver drives over them. And they are often simple to build, but are only good for game elements of one specific size. So active intakes include rollers, rubber bands, tubing. We'll show you guys them like right now. Compliant wheels. So you see these green things in the image right here, those are compliant wheels, and basically they're spinning and they are made of this sort of rubber material, and they're really good at picking up these like small elements. So they're very controllable, but they can only pick up one element at a time, and it can get jammed up